Hello, my name is Bruce Whitfield, and this is homework 5. Right here, you're looking at the VHDL for T flip-flop with an asynchronous clear. I've set it up with an entity with inputs of T, clear, and clock, and they're in standard logic. And then the outputs are Q and Q bar, also in standard logic. I've set up the architecture for the T flip-flop with a signal. Now this signal holds the value of Q. And I have a process. Now the process's sensitivity list has clock and clear in it. Now, if clear is 1, then temp is equal to 0. This if statement right here is looking to detect when clear is 1. This else if statement right here is looking to detect the rising edge. And if the rising edge is detected, then temp equals not temp, which means that Q equals not temp. And much like with the if statement for the clear, if clear is enabled and temp equals 0, Q equals 0. Now moving on to the test bench for the T flip-flop, I have it set up in this fashion. I have the entity declared and the architecture set up with the signals being the inputs and outputs of the T flip-flop with an asynchronous clear. Right here I have created a component for the T flip-flop, and right here I instantiate it. Now, you have 3 inputs, so there are 8 different possibilities. And a T flip-flop responds to the positive edge. But it is important that first and foremost that clear is enabled with clock and T equal to 0. This allows for you to have values to work off of with the T flip-flop. Without it, you would get no outputs in the waveform. Next, let's move on to the waveform of the T flip-flop. So when T is 0, clock is 0, and clear is 1, Q is 0 and Q bar is 1. And that is because clear is enabled. Next, you have T, clock, and clear are both 0. So Q and Q bar hold the values 0 and 1 still. Next, you have T is equal to 0, clock is equal to 1, clear is equal to 0. And this results in Q equaling 1 and Q bar equaling 0. Next, you have T is equal to 1, clock is equal to 0, clear is equal to 0, and because of the fact that the clock is disabled, the values hold for Q and Q bar at 1 and 0. Next, you have T is equal to 1, clock is equal to 1, and clear is equal to 0. Because T is equal to 1, and it is the rising edge of the clock, it toggles, and Q becomes 0, and Q bar becomes 1. Next, you have T is equal to 1, clock is equal to 0, and clear is equal to 1. Because clock is 0, no values are being passed, and clear is 1, so the values hold at 0 and 1 for Q bar. Next, you have T is 1, clock is 1, and clear is 1. If clear was 0, the values for Q and Q bar would toggle. But because clear is equal to 1, the values remain the same for Q and Q bar at 0 and 1. Next, you have a continuation of the same wave, the same values. So this is a waveform for T flip-flop with an asynchronous clear. As you can see, the clear causes Q and Q bar to set to 0 and 1, and whenever clear is 0, clock is 1, and T is 1, the values for Q and Q bar toggle. This is the end of my video.